Good afternoon, everyone, and welcome to today's PTV Talk session. Today, we have a presentation from our PTV expert, Adam Groves, on PTV Visum, and we have our moderator, PTV expert, Chetan Joshi, to answer any questions. Just a couple of items before we get started with the presentation. At the end of each session, we will have a Q&A. You can enter your questions in the question box at any time throughout the presentation, and Chetan will answer those, and we'll answer as many possible questions at the end of the presentation. Our next PTV Talk session is PTV Visum on April 6th and PTV Publisher on April 20th. These sessions will be emailed separately to register. And last, if you are interested, please join one of our next web-based training courses. We have PTV VisWalk training on March 29th, which is coming up probably next week, and PTV Visum for reviewers on April 19th. You can find more information about these trainings, pricing, and registration at ptvgroup.com under Events and Training. And I'll pass the baton to Adam.
All right, thank you very much, Tiffany. And thank you to everyone joining us this afternoon. My name is Adam Groves. I'm a PTV America based out of our Arlington, Virginia office, and Chetan Joshi's on the line for me as well, who is one of our principal engineers based out of the Portland office. And we're talking about modeling public transit in Visum today. So Visum contains a really huge set of features relating to public transit that take you all the way from sketch planning all the way to really detailed operational tools. Today, we're primarily going to focus on the basics as it relates to travel demand modeling. We're not going to do a ton of hands-on training today. We can jump into software and take a look at a few things though. If you do want to see some videos or tutorials as far as how to do some more hands-on things like adding stops or editing transit network, we do have some resources you can find at ptv.to/learn. That's our technical resources archive, and there you'll find a couple things that can help you out. One is to getting to know Visum series, as well as some of the trainings we did for the models for the Florida Department of Transportation. And those are going to dive a little bit more and show you some things like network editing as it relates to transit and things like that. So it's just some good resources. Along with within Visum, there's a first starts tutorial that walks you through a lot of those things as well. So if you want to get a little bit more hands-on training, those are some great resources to start with. As far as what we're going to cover today, we're going to start out and talk a little bit about just an intro and a little bit of overview of what we're going to cover. We'll go through transit network modeling and how Visum represents transit networks in the model. We'll talk about assignment methods and skimming, talk about some post-assignment analysis. Then we'll talk about a little bit of these kind of extended transit functionalities that are in Visum that you may find helpful. And then we'll go ahead and do a Q&A session at the end. So with that, we'll go ahead and get started. Just as an overview, as I mentioned, right now we're going to primarily talk during this conversation about travel demand modeling and how Visum transit functionality relates to that. There are quite a few other extensions that you'll find that maybe go beyond what you see in typical travel demand models and focus more on things like transit providers, fleet planning, things like that. These things could be things like park and ride, accessibility and equity analysis, vehicle sharing, like bike sharing, for instance. Look at how you can plan fleets and manage investments. Look at infrastructure for things like electric buses and their charging infrastructure, do cost benefit analysis, look at ride sharing for first and last mile service. So these are kind of these extensions I was talking about that we'll talk a little bit more about later. So there's a wide array of tools you can integrate in or use to extend your model as well. So we'll go ahead and start now and talk a little bit about Visum's transit network model. So within Visum, the network model consists of transit stops, links for representing all the roads and rail tracks, transit lines, and all their attributes. These are all designed as hierarchies, so you can model a wide range of different systems. So from very simple systems to very complex systems, but this also can help you manage kind of the resolution of your model, just depending on whether you're doing something very high level like sketch planning all the way down to fully operational models. So you can kind of choose based on the type of system you're trying to represent and what level of detail you need about how you implement the network model. From a stops perspective, there's three main elements that we're going to talk about. First is going to be stop points. So these really represent a boarding location. These could be on a node or link. So this is be the point at which a person actually boarded the transit vehicle. The next highest step up is a stop area. So these represent stop one or more stop points and connect them to an access node. This can also be very important for some activity-based models that use a three-zone system. We can do these kind of transit access points, and we now have stop-to-stop skimming as well within Visum, which we'll talk about a little bit later. And then we'll go to stops, which is kind of the highest level. So this represents a group of connected stop areas. The picture on the right kind of gives you a good representation of what more like a multimodal or like intermodal hub would look like. So you have something like the VRE system here, which is a commuter rail. So it would have its own stop point and stop area. And then the bus system here would have two different stop points where two different stops are located, and they'll be within the same stop area. And then the metro rail station would be a stop point and its own stop area. But all these are considered one stop for the purposes of this particular network model. You can also use this to represent really kind of complex station designs. So in a case like this, where you have maybe an underground metro rail stop, you could represent the whole stop. Above the street level, you could have a stop area and stop point for the bus. Each platform could be a stop area, and then those individual stop points exist where those trains will be stopping. So you can also represent these stations in really complex detail, look at things like walk transfer times, all that kind of analysis as well. All that seems kind of complex, but as I mentioned, you can always collapse that stuff down into a much simpler representation. So you can also have a one-to-one relationship so that for a particular stop, you have one stop area, stop point, which are basically the same unit as well. So you can use this to represent whatever level of complexity you need for your particular project. Now for the line hierarchy, we start at the bottom. Which is a vehicle journey. So this is used in the timetable assignment, or if you pull the data in from something like a GTFS import, you'll get this. These represent actual vehicle trips along the transit line. And then the vehicle journey item is one step below that, which are those individual path legs. Moving up are time profiles. So these are individual runs along the line course route, but they could have varying run and stop profiles, something like an express bus versus a standard route. Then you have a line route, which defines the course and direction of the transit line. And then the line is the kind of overall container. So like here in the DC area, we have the metro rail system. So like the orange line, red line would all be lines. You do optionally have the main line if you want to have one further step of aggregation as well. You also have the ability within the network structure to represent headways for each particular time profile. You can update run times from the link level attributes for speeds. Also fare modeling, so the Visum contains quite a few different fare systems that can be modeled. So things like zone-based, distance-based, from and to zone-based fares. So you have kind of a wide array of methods for representing fares. As far as building your transit network, there's quite a few different ways to automate this. It's kind of mentioned a minute ago, you do have GTFS import, so you can import GTFS. That's going to give you a really nice representation of the network, also from places like OpenStreetMaps. You can also import any kind of existing network that you have from maybe another travel demand modeling software, and also from things like Excel or text files as well. So a lot of different options for importing networks rather than having to build everything from scratch. So I kind of mentioned, we're not going to talk too much in detail about network editing, but just to note here, all the network editing can be done right within the Visum network editor. So you can add or remove stops, lines, do extensions or modify, change fares, headways, and all those sorts of things easily. And of course, as always with Visum, you get the benefit of having the fully integrated multimodal data model. So, any changes you make to particular network items will cascade down through the rest of them. So if you modify a link, for instance, that a transit line goes through, changes geometry or something like that, it is going to update the transit line as well. All the stop areas and stops are connected, so you do get the benefit of having all that connected, and it makes it really difficult for you to, for example, break the network by accidentally deleting something. One good thing we do like to point out as well that you do have access to under the calculate menu is the network check. So as you are doing any edits or coding the network, you do have the option to go and use this network edit and check for things like maybe zones that aren't connected to the transit network, find various links without walk times, things like that. So this really is helpful if you have a large network and helping kind of like QA, QC all those network elements. With that, we're going to move on to assignments and skimming. And we're going to talk a little bit today about the different assignment procedures you have available to you within Visum, and what's required to run them and what kind of outputs you would get. So we kind of classify the various transit assignments that are available within Visum as follows. So they have a transportation system based, a headway-based, a schedule-based or timetable-based assignment. There's a direct assignment, which is used for assigning something like transit ticketing data to the network. And we also have a multimodal assignment as well. And so we'll talk a little bit about how each of these works. So we'll walk through these right now, and we're going to talk a little bit about what's required as well as what the outputs you'll get for each of them. The first one, and the reason this is grayed out, we're not going to spend too much time on this, is the transportation system-based or TSYS-based assignment. So this is what you would use basically if you didn't have really any information about the transit network, the lines, timetables, anything like that. So it's a very simple assignment. We typically wouldn't recommend you use this except in really specific situations. This can basically work along with just nodes and links. And you're going to get really basic volumes on your links, basic skimming available, and basic select link analysis. Moving on, we have the headway-based assignment. With this, you also need those line routes defined and time profiles. This is going to give you a little bit more information as far as outputs. You're going to have volumes on the links and the lines, as well as boarding, alightings, and transfers at stops. You're going to have the ability to record transit path legs. You'll get a lot more skimming options as well, both zone-based skims for time, distance, and quality, but also stop area skims for time, distance, and quality, as well as some more fare options, better select link analysis, operating indicators for the transit system, as well as GTFS import-export capability as well. Next, we will move on to the time-based assignments, which are going to be primarily that direct assignment of ticketing data and the timetable-based assignment. The timetable-based assignment opens up a really much wider range of capabilities as far as analysis, as well as some other cool things. You get individual vehicle journeys. Can get the skims not only for the entire assignment period, but assignment time intervals within the assignment period. You'll get access to dynamic select link analysis, transit isochrones. One really great thing too that the timetable assignment introduces is the ability to integrate that with a variety of other modes of transportation. So that can be vehicle sharing, so things like bike shares, or it could be ride sharing for first and last mile service. So either dial a ride or TNCs like like an Uber or Lyft type service. And these are integrated in with the timetable assignment, so you don't have to treat them as a separate mode, but rather those vehicle and ride shares become individual legs to a public transit journey. So it really helps you represent those kind of a little bit more complex journeys. This also introduces the ability to do either discomfort or capacity constraints as well. So you can represent capacity constraints in the timetable assignment in a couple different ways. The first is what we call soft constraint, which is a volume to capacity ratio dependent impedance. Or you can also do a fail to board, which will actually prevent passengers from boarding full vehicles and push them back to the next vehicle that comes through. And as you see here, you get a lot of additional additional capabilities as far as analysis, both, looking at passenger delay, ticketing data, transfers, cost analysis. It really opens up a really wide array of analysis to you that you don't have necessarily with the headway-based assignment. A little bit how the transit assignments operate. So these operate in primarily two steps. One is in which we find paths on the network, which are either routes or connections. So routes are what we use when frequency or headway is given, which gives you an estimated waiting time. Or connections are used in the timetable assignment, which actually gives you a calculated wait time. And then those volumes are allocated to those routes or connections within the network. So one of the strengths of Visum is this allows us to represent, the full customer journey. So all the way from home to the destination. So taking into account things like access time, waiting time, vehicle time, transfer time, and egress time. So you'll see the ability to pull this data out of in various ways from Visum in form of SKIMS or attributes on particular network objects. So there are a few different ways that within the assignments that people access, egress, or transfer into the transit network. So the first is kind of fixed access egress times that are done on the zone connectors. So you can define on those zone connectors what the access time or egress time would be. This can also be calculated with the PT walk or PT auxiliary modes. So this is actually computed access. So you can look at things like walk times if you have the walk network. You can also access via vehicle sharing or ride pooling, like we discussed a minute ago. And also have the ability to consider things like either park and rides or multimodal trips as well. So these represent kind of a lot of different ways that you can move around within the transit network. So there's a number of different strategies for pathfinding available within the assignment. So for the headway-based, you'll have the ability to compute optimal strategies or have advanced passenger information. On the timetable-based, there's a shortest path, the branch and bound, and also the ability to use pre-computed connections that you've saved to a file can always be loaded as well. So we'll take just a minute to kind of do a little bit compare and contrast on the headway versus the timetable-based assignment, which is the primary two methods of assignment that we typically see people use. So for the headway-based assignment, travelers know the network, the line frequency and running times, but not actual departure times. Whereas with the timetable-based assignments, travelers know the full network and full timetable. So they're assumed to have all the information at their disposal when making decisions. With headway-based, travelers either may or may not assume that there's a fixed headway. With the timetable-based, punctual service is assumed. With the headway-based, travelers decide at each transfer point based on strategy and observations. With a timetable-based assignment, travelers consult the timetable and select their full connection before they embark on the trip. With headway-based, impedance is perceived journey time plus fare. With timetable-based, there's impedance is perceived journey time plus fare plus deferred departure penalty. As far as access, as we discussed, you can have walk legs, auxiliary access, and transfer times are considered. We also have the ability with the timetable to extend that as well to include the trip chainings. When it comes to capacity constraints, there are some things you can do as far as scripting with headway-based, but the timetable-based, both that discomfort, soft capacity constraints, and hard capacity constraints are included in the assignment, and you can include them. Timetable-based gets you the ability to do intermodal trips with vehicle sharing and ride sharing. And when it comes to things like volumes and skims, for the headway-based assignment, that's going to be fixed for the entire assignment period, whereas the timetable-based assignment gives you access to those per time interval dynamic volumes and skims. And so with the headway-based, it's very fast because there's a little bit less going on there. The timetable-based is still, though, very efficient, and considering the amount of extra information you get out of the assignment, the computational penalty is very low. And as far as outputs, you get the line and link volume skims and select link with the headway, but with the timetable base, those become dynamic, and you also have access to isochrones and all those other analysis tools that we saw earlier. So let's walk through a little bit about the procedure of the headway-based assignment. So the first is going to be headway calculation. So there's a couple different ways you can get this. First is a fixed value from an attribute. So if you know that a particular line route has a 5-minute headway, you put that into an attribute, you let the assignment know what attribute that's stored in, and that will be what the assignment uses. But in many cases, for example, if you do a GTFS import or an OSM import, you may have access to a detailed timetable within your network. If you do have the network with a detailed timetable, you can still use that for a headway-based assignment. There's a couple of ways that headway gets calculated. The first is the mean headway according to the timetable, and the second is the mean wait time according to the timetable. So you have your choice of deriving those headways from either of those methods within the headway-based assignment. So I won't go too much detail into the path building, but I want to leave this in the presentation, just if that'll be sent out later, just so if you want to take a little bit of a look as far as how the multipath building is done. We can also look a little bit about the fare and the impedance. Point out here, one interesting thing is you do have the ability to add transportation system specific factors into this perceived journey time for the purposes of calibration. So you can use this to basically make modes either more or less attractive. So if you're trying to represent how people are more likely to choose, for example, a rail line than a bus journey, you can use that to help accomplish that. Now we mentioned that there's a few different strategies for determining route choice. So within the headway-based assignment, these are those strategies that you have a choice of. Again, not going to go into too much detail, but you can see from left to right, you can choose kind of how much advanced information those passengers will have before they select their route, all the way from, they don't know a lot to the point where they have a complete information about the timetables, similar to the timetable-based assignment. One thing to note as well is how coordination is handled whenever there's parallel services between two stops. So you see here we have stop 1 and stop 2, and there's both that red and blue line servicing, sharing those stops. They both had 20-minute headways, so you can have it so that the services are assumed to be interleaved. So rather than assuming that, for example, a red line bus comes and 1 minute later a blue line bus comes and no other bus comes for 19 minutes. This is basically average, so that you assume that the headway is now 10 minutes, because we're going to assume that the system is coordinated in a way so that those stops are spaced out. You can also have estimated or fixed transfer times. So that's something you can edit at the stop level. And again, we're going to bring back this graphic here as we go to talk a little bit about skimming, because this kind of shows you all these various access times, wait times, transfer times, also available with skims. So you have a few different aggregation functions that are available for the headway base. You can have average, a quantile, weighted by volume. You also can change the scope of the skims here from being either zone to zone or stop area to stop area skims as well. You can kind of see there some of the skims you have available to you in the headway-based assignment. I can also, within Visum, set up a bunch of parameters as far as how those skims are set up for custom values for example, diagonals or what the minimum maximum would be, as well as things like units of measurement can all be set up within the general procedure settings. So we walk through the SKIMS a little bit. We kind of put these into kind of broad categories. So the first is time-based SKIMS, so things like journey time, in-vehicle time, transfer time, walk time, and all the others you see on the screen there. Also, there are distance-based SKIMS. Quality-based SKIMS is relate to fare, service frequency, risk of delay. So there's a number of quality-based SKIMS. With that, we're going to go ahead and move on to the timetable-based assignment. So the timetable-based assignment, you're using basically a more realistic representation where you have an exact timetable just like you would in real life. And this is just a representation of one of those timetables. So as far as the steps of the timetable-based assignment, first there's a connection search where they find a set of connections for each OD and departure time. Then the connection impedance is calculated, so to assess the quality of the various connections. And then the connection choice is made, and the choice model for distributed demand to those alternate connections. So I mentioned this connection search, there's a couple different options. The first one that's typically used is the branch and bound connection search, which is use a multi-dimensional search impedance. And you can also limit the search tree width, but there's also a shortest path connection search or the ability to use a previously stored connections from a file. And you still have access to the calculation of the perceived journey time. So you can go in and change coefficients here and parameters as far as things like wait time, transfer time, number of transfers. One interesting component as well is you can do a kind of hybrid assignment using both the headway and the timetable-based assignment. So for particular lines or transportation systems, like maybe you want to represent the light rail system with a timetable, but maybe some bus systems with a headway-based, you can do that. And this is done by flagging those with an attribute at the line level. And you can then choose the headway. And so this allows you to do kind of a hybrid assignment with headway and timetable. So also note a question we do get sometimes is either I only have headways in my current model, but I would like to use a timetable-based assignment, or vice versa, where maybe you did a GTFS import and you have a detailed timetable, but you want to use the headway-based assignment. The good news is there's capability to go back and forth between the two. So if you only have headways and would like to generate a timetable to be used with the timetable-based assignment, you can do that through the create regular timetable procedure that's available in the add-ins menu. This basically allows you to define start and end time and headway, and it'll generate all that timetable information that you need for the assignment. Within the headway-based assignment, within the assignment parameters, you can choose the calculation modes that we talked to. For example, the mean headway according to the timetable, and use that to generate the headways that are used for the headway-based assignment. You can also output those to an attribute as well and store them for later use. Also, as we mentioned, it's really easy to import GTFS data. It's going to give you access to, in a lot of cases, especially for larger transit networks, a really, very detailed timetable, including, timetables for individual days. And there's some, capability in there to aggregate and simplify data as well as when you do that import, you can map match it to an existing network. So that'll actually like map match those bus lines to your existing private transportation network in the model if you have one, and for other things like removing the zigzags where the bus stops as well. We do have the capability as well for either for a variety of purposes, either analyzing them independently or maybe for calibration data, validation data. We do have the importer for external passenger trip data as well. So these are typically held in some kind of text or Excel format. This can be check-in, check-out data, either system-wide or per vehicle. More often than not, we see the system-wide, for example, in like a metro system where you'll check in as you enter the system and leave and check out as you leave the system. So this can be directly assigned to network, so you can use that kind of ticketing data to see how passengers move throughout the network. This is something that was improved and sped up quite considerably for the last release. I do want to mention just briefly too the multimodal assignment. So the multimodal assignment works a little bit differently. This is using some really long-range models for accounting for people using multiple modes. So in a case like you see this diagram in the middle, where you may have someone who takes a car to an airport, takes a plane to another airport, and then a rail to their final destination. So rather than being an independent assignment method, this kind of works as an overall assignment method, and so the skimming and assignments are still done for the individual modes, but this really allows you to chain those trips up and view these kind of long range trips. This is a little bit different than what I spoke about earlier with the on-demand service being integrated into the timetable-based assignment. So this is an option, so just be aware if this is something that may work for one of your projects. This is available. This also has the ability to force a main mode of transportation. So you could say, for a certain, everybody has to take the metro, at least for a portion of their journey. So just be aware that that's something that is available. All right, we're going to talk a little bit now about options for post-assignment analysis. So the kind of simplest version we have here is your standard link volumes. In the case of the timetable-based assignment, you do also have the ability to vary these across the time intervals, and you'll see the highlighted section up here. You'll get this time, and this will actually, you're able to step through the model and see how those link bars get generated. You also have with the headway and timetable-based assignments these full path storage, so you can really dive down and see what's happening at the path level, what the journey times are, speeds, transfer times, all those sorts of things. And also have the departures, individual departures stored as well within the timetable-based assignment. And so you can go through then and filter these path legs based on certain attributes. So you can look at extract particular types of information. So in this case, you look at something like this with, that has at least, one walk leg, for example. You also have quite a bit of opportunity to analyze matrices as well. You can see here on the screen, you can do things like matrix histograms. You can sort and filter those matrix values. You can color code them. You can do this kind of side-by-side display and synchronize with the map. And with those matrix distributions, you can do trip length distributions, travel time distributions. You can also do scatter plots as well. So you have a lot of powerful capability for analyzing those matrices. You also have the ability to do select link analysis. We call that a flow bundle, and it extends past select link because you can also do select zone, select node, stop area, stop point, or sharing station. So as always with Visum, these are done on the fly. So as long as you have stored all of the paths from your assignment, there's no need to mark any of these network objects. If you need to analyze them later, you can do all that information on the fly. You can also do things like time restrictions, passenger type, things like that as well. Flow bundles or those select link zone stop also can be used to generate formula matrices per demand segment. So you can look at matrices for the flow bundle as well. You also do things like isochrones and catchment areas. So this is all done on the fly as well. And then you can store those for various objects for use in your analysis. Also, as always, you could do desire lines, so looking at various displays of OD data. Then you can also look at activity profiles for various things like different types of activities such as vehicle journeys. This also works with ABM activities if you're working with an activity-based model. Look at line blocks as well as things like vehicle occupancy for DRT or vehicle sharing as well. Now we'll walk through some additional features, some of those kind of extensions of the transit system in Visum. So we have quite a extensive fare modeling system for estimating revenues and considering fares as a connection choice. You can go from very simple approach, it's distance based, so you can do really detailed with multiple tickets, multiple fare systems. And there's 4 different ticket types, which would be distance based, zone based, from 2 zone or short distance. And there's some other things you can do as far as discounting and supplementing as well. So you can really represent a lot of complex fares within the system as well. As we kind of talked about the capacity constraints, with the stall capacity constraints, this is affected before the trip because that's part of something that gets considered in the impedance, and this allocates passengers to alternative connections when there's really crowded legs. There are a few different functions for determining the curve of that impedance, and those were primarily came from a couple of our customers. So you have standing minutes from DB, penalty on in-vehicle time with Swiss Rail, or the standing density as well. The fail to board, this affects the route choice during the trip because passengers get allocated to alternative connections when they experience overcrowding. So this will actually prevent people, as the name would suggest, from actually boarding that vehicle. So as we mentioned, we do have the shared mobility and intermodal trip option. So there's a lot of ways to consider various ways that people either access transit or use transit to access other modes. One of the most interesting uses, and one that we get most questions about, is probably as far as the ride sharing simulation. So this can be done to simulate like a dial-a-ride or TNC operations. So this actually uses more of a microscopic simulation where it's actually generating the trip request, and then a tour planning algorithm goes through based on the fleet that you've outlined and plans those individual tours as pickups and drop-offs. Then all that information gets aggregated back up as well. So this can be used both independently as a separate mode of transportation, or it can be used along with a timetable-based assignment as a leg of a public transit journey. So this is a really powerful tool. You can use this to simulate multiple fleets. You can look at the size of your fleet, the seat capacity. You can change some of the settings as far as how long before people will pre-book their trips, as well as how long they're willing to wait. And you'll get a lot of outputs as far as things like what the service level was for those riders. So there is an example, a ride-sharing example within the examples directory within Visum. I'd encourage you to check out if you want a little bit more information about this, because this is a really powerful tool. Vehicle sharing as well. There's a vehicle sharing example. So you can look at things like car sharing, bike sharing, micromobility, things like scooters, things like that. There's a variety of options for what types of systems those are, whether they're a one-way station-based or just floating. And look at all those things like capacity, rent return time, vehicle relocation as well. We'd also represent parking rides, so you can look at parking ride lots, capacity. Again, there's an example that provides a pretty good example of how this is used within the installation. Also do things like analyzing transfers with this transfer display of regular services graphic, which is quite interesting. You also have the ability to analyze timetables, looking at things like either in a tabular form or a graphical form. And then getting into a little bit more advanced, you have the ability to do schematic line diagrams as well, which is a pretty typical transit tool, as well as line blocking. And most interesting here for a lot of people is that you can use this to look at battery powered buses and trains. So you can look at charging rates, consumption rates, consider charging, and you can really look at how you can set up your transit system to work well with the electric vehicles. There's also a scheduling optimizer for vehicles as well that can be used for standard vehicles as well as electric ones. And we also have a headway offset optimization as well. I think with that, we're going to go ahead and move on to the Q&A portion. So if you have any questions, please go ahead and enter them in the questions and answers box if you have not already. I guess, Chetan, if you'll let me know if there's any questions.
Yeah, so far we got some questions on the chat and I've answered those.
Okay. So let me take a look here. One question we got here, just to put it out to the whole group, was about importing GTFS into a existing roadway network. So the typical workflow for that would be that you would open a new Visum file, import the GTFS file into that Visum file and save it, then go into your other network and use the import PUT supply from Visum. So it's kind of a two-step process if you're importing that transit information to an already existing network. One question relating to as well to demand input. So with the headway versus the timetable-based assignment. So for the timetable-based assignment, it works similar to the dynamic assignment on the highway side. So you either need to have a time series specified where, for example, what percentage of the demand is entering the system per time period, or you can do it also as multiple matrices and define a matrices time series as well. So that would be a little bit of difference versus the headway-based assignment.
Seems like a question about elaborating a little bit more on the on-demand service with the timetable assignment.
Mm-hmm.
And what inputs are required and the requests getting generated.
Okay. Yep. Actually, what might be the easiest is for me to hop into Visum real quick. Now, if there's anything you want to talk about while I'm doing that, Chetan, related to that.
Oh yeah, I was going to suggest the same to demonstrate the parameters in it. Probably better.
All right. So if you go to what I went to the procedure sequence and open the parameters for the timetable-based assignment, and then if you go to this extended consideration of transport supply, here's where you're going to enable things like the capacity constraints or use, in this case, the DRT. Then if we open that up, you're going to have some parameters you define. Like I mentioned kind of earlier, pre-booking time, maximum wait time. Also, whether you want to permit only active nodes as pickup drop-off points. So you can kind of lock down what nodes are available to be used as pickup drop-off points, and that may vary a little bit depending on if it's like a door-to-door service, or maybe in some cases you may want to have people funnel to specific pickup drop-off points. There's some things for things like detour factor. You can output SKIMS for the DRT as well. You do need to define some fleet characteristics, so you can have the number of vehicles, the number of seats per vehicle, whether or not multiple trip requests can share a vehicle, and then also, there's specific detours and things associated with that as well. And then the tour planning, so you would define the transportation system of the vehicle fleet, and then you have the ability to use this kind of slider to focus more on optimizing for fewer vehicles versus serving more trip requests. And here's where you can also define some things like holding areas. So you can set up holding areas. So if a particular vehicle doesn't have a pickup with the next has been sitting idle for a certain amount of time, they'll return to one of those holding locations. You can also use the setup to have nodes that are charging locations if you want to consider electric vehicles. And then there's some variability in the supply as well. So those are kind of like the general things that you would need to define in order to use that. All right, and so looks like there's also a question for headway-based assignment. You showed a slide indicating that crowding was a factor in route choice. Can you explain more about how it differs from the discovered hard capacity constraints in the schedule-based? And the answer to that is the headway-based discomfort factor is applied as basically like a penalty or shadow price, so that gets factored into the overall impedance during the assignment. So the time versus the timetable assignment, which allows either hard constraints or the shadow pricing method. All right, we'll give it just one more minute to see if any other questions come through. All right, so one question came through: where can we find more details on the methodologies of the various transit assignment methods and add-ons? The perfect place to look at that, there's two major places I would tell you to look at that. The first is going to be for like the more detailed information is the Visum manual. So if you go to help and PTV Visum manual, you bring that up, and there's a really extensive manual that really goes through all the individual procedures in a lot of detail and how they work together. And then, as I mentioned, also, if you go to help examples, open examples directory, there'll be a lot of different examples for on various methodologies like ride sharing, park and ride, vehicle sharing. So you can actually see, and usually these will have an explanation in a PDF in that directory as well, as long as some different graphic parameter files and things like that. So if you want to kind of see how that gets applied and what kind of inputs and outputs you have, that's the best place to look for sure.
Yeah.
Also, one thing that's always helpful to me too, if you're somewhere like these in the assignment procedures, you can always just hit like F1 and that'll take you direct to the online help for that dialog box that you're looking at.
There's also just the general idea that in the user manual, we divide it into two sections. One is the fundamentals, and then the other one is usage. So if you want to take a look at some of the more theoretical aspects of it, you can look at the user manuals and the fundamental section, which describes more of the theory behind the methods. It's another question on which out of the 5 are generally used in terms of assignment these times. So generally for a lot of the Visum applications tend to be in the timetable-based assignment format, the branch and bound method. But in the US, there's more significant use of headway-based assignments in general. So we have applications of both in the US over here. For example, some agencies prefer to use headway-based assignment, which is more the standard over here in the US, versus some agencies, for example, Delaware Valley DVRPC and Winnipeg, they have the timetable-based assignment that they're using.
All right, I think with that, we'll go ahead and wrap up. If you do have any questions, please feel free to reach out to us directly. My email is adam.groves@ptvgroup.com. I believe in the follow-up email, there'll be a link to contact me as well, or a link to schedule a meeting. So if you have more questions or need to see anything more detailed, please don't hesitate to reach out. Other than that, thank you to everyone for attending. And Tiffany, anything from you before we head out?
Just a reminder that we will provide a recording of this session sent in the follow-up email as well.
All right, perfect. All right, thank you so much everyone for attending, and we look forward to seeing you next time.
Thank you.